Hello, I'm Dr. Millicent Thomas. I would like to explain about the relationship between two bivariate data and a measurement called the correlation coefficient R. The main objective of this video is to find the correlation coefficient R between two bivariate values x and y, and also to know the facts about the correlation coefficient R. The coefficient R is obtained using the formula sum of xi minus x bar by sx multiplied by yi minus y bar by sy and dividing by n minus 1, where x bar is the mean of x, y bar is the mean of y, sx is the standard deviation of x, sy is the standard deviation of y. We have seen the regression line in our previous chapter. When we have a scatter plot, we know how to get the regression line. Suppose if the diagram looks like the one what we see in the first figure. It looks like it has a negative slope. When it has a negative slope, the coefficient will be negative. If the slope of the regression line is positive, then the coefficient R will be positive. If there is no relationship at all, if there is no relationship like the one what we see here in equation, the figure 3, then the coefficient will be 0. If it is spread all over, then there is no relationship between these two. The coefficient R always lies between -1 and +1. That is, we have -1 less than or equal to R less than or equal to +1. The strength of the relationship increases as R moves away from 0 towards either +1 or -1. So if it is closer to -1 and +1, then you're saying that the strength increases. If R is near 0, then it has a very weak relationship. If R is close to -1 and +1, indicates that the points in the scatter plot will be close to the straight line. If it is exactly equal to 1 or -1, then it has a perfect linear relationship. This R has no units. This R value will not change when we change the units of x and y. It is not resistant because it is calculated using the mean and the standard variance. And also, even if you flip the values of x and y, the explanatory variable and response variable are changed. Still, the coefficient will be the same. The correlation coefficient will not change even if we flip the values of x and y. In these diagrams, we have various coefficients. The coefficient is 0 if the values are all scattered all over. It looks like this has got some positive linear relationship, and here in this case the points are very close to the line, and here it has a negative linear relation. Here again it is negative, but points are a little closer and it lies almost on the line. So we can slightly guess the correlation coefficients for these scatter plots. In this video we learned about the correlation coefficient and what it is, and also the formula and how to judge the coefficient when a scatter plot is given. In my next video, I will explain how to get the coefficient using TI graphing calculator. The formula for the correlation coefficient is sigma xi minus x bar by sx times yi minus y bar by sy divided by n minus 1. Since it is hard for us to do it manually, it is easy for us to get the values of the coefficient using TI calculator. So in my next video, let me explain how to get the coefficient using the TI graphing calculator. Hope this video was helpful. Thank you for watching.